class loaders. So I will show you a demo, live demo in IDE first, then I will go to the presentation. Okay, this is my IDE. Here I have created one class loader demo class. Inside that I have one application class loader, one platform class loader, one bootstrap class loader. So let us see how this works. So let me run this. So here you can see the output. So here application class loader, you can see it is printed here, jdk.internal.loader class loaders application class loader, and platform class loader also printed here as platform class loader. Bootstrap class loader will print null always, because bootstrap class loader is the base and it is written in native language C bar C++, so that it cannot print like a Java object. But application class loader is a Java object, platform class loader prints a Java object, but bootstrap class loader prints null. Since it is not written in Java, it is written in native language like C or C++. So here in the code, you can see the syntax. Class loader demo, this is my class name, right? Our class name. So class loader demo dot class dot get class loader. So it is printing like application class loader, means it is the application, our own application. So it is application class loader. Then here I am getting class loader. This is a inbuilt object in java.lang. Okay, this is inbuilt class. So this class loader dot get platform class loader, it will give us platform class loader. So here you can see it is printing as platform class loader. And bootstrap class loader is, we have to use some core classes like string. Okay, if you are writing like this, string dot class dot get class loader, it will print null, because this is written in C or C++. It is the parent of all class loaders. It is the base of Java. It is written in C or C++. All the core components written in C or C++. So that's why the bootstrap class loader prints null. It's not written in Java. It cannot print a Java object. So I will show you another example of parent delegation. Here you can see I am creating a class loader object. So this is our class, right? Parent delegation demo class dot class dot get class loader. So I have got one class loader here. So here I am doing is, it's a while loop while CL not equal to null. When CL becomes null is for bootstrap class loader, right? Because CL inside you can see CL equal to CL dot get parent. So finally it will reach the bootstrap so that CL becomes null. Then this loop will terminate. That is the end of this loop. So you can see how it is running. You can see in the first iteration it printed application class loader. This is our own class parent delegation demo. It is application class loader. It printed here. Then its parent, it is platform class loader. Then its parent, it is bootstrap class loader. So this is hierarchy. This is our own application class. It is loaded by application class loader. Then its parent is platform class loader, and its parent is bootstrap class loader. So this is the hierarchy. For this I am simply iterating like CL class loader equal to get parent like that. It will reach till bootstrap and it will print accordingly. Okay, this is the parent delegation demo. Then I will show you another demo, the class loading difference. So here you can see I am using two types of class load, two types of loading. One is with the load class. Load class, inside class loader we have get static method, get system class loader. Then we will load class like com.java demo virtual my class. So my class is a class created by us. Here you can see my class. Okay, what is inside my class? So this is my class. In my class, nothing is there, only one static block. Inside this static block, I am just printing my class static block executed to know whether this static block is getting executed or not. Okay, so here you can see first I used load class. So in load class, that static block didn't execute, right? Next, here I am using for name. You can see, right? This is using class.forName, system.out.println. So class.forName, still we have to give the fully qualified name, including the package name, like that, then only it will work. Okay. So com.java.demo virtual.myclass. This is my class with the package. So here after printing this system dot using class.forName, it is printing my class static block got executed. Means if we are using this class.forName, it will execute the static block as well. Okay, the load class will simply load the class to JVM. That's all, nothing else it will do. But class.forName will load the class and it will execute the static blocks. That much is happening when if you are using class.forName. This is two different ways of loading class. Okay. Okay. Then I can show you another demo, class source. Okay. So this is a class source demo. Here inside main class, I have created one object called class. So it will simply returning the class of my class source demo. So here I am printing class loader class dot get class loader. Then I am printing code source class dot get protected domain dot get code source dot get location. So it will print the location. So first line it printed class loader, it is an application class loader. Okay, then source is inside file. This is the path, users, finish, projects, demo project, target classes. So this is from this source it is loading the class. Application class loader loaded the class from this particular location. So this is a demo to understand from where it is loading and what is the path where our classes will go, like that. Okay. Then a simple custom class loader demo. Okay. So here in simple custom class loader, if you want to create a custom class loader, you have to extend the class loader. Okay. Then what you have to do? You have to write class loader custom cl equal to new custom class loader. Then what you are trying to do here is you are trying to load java.lang.string. So how it will work? It will not work, right? Because it will print null. Because as you know, the Bootstrap class loader will print always null, right? So here this class, the class loader tried to the java.lang.string means it comes under Bootstrap class loader. So Bootstrap class loader here we are using, that's why it is printing null. So if you want to, you can have different types of class loaders. Here this instead of this you can give something else as well, so that you can see the difference. So let me try with this how it will behave. This is my own class, right? Simple custom class loader. I am trying to replace here. Let me run. So it printed application class loader. Okay, means this comes under application class loader. What if this class is not available? Suppose I am renaming my class to my class 1, which is not available. How does it will behave? Let us see. You will get one exception. My class 1, it is not available. It's a class not found exception. So this is a very common interview question when you will get a class not found exception. So when you will get a class not found exception means when you are trying to load a class that doesn't exist, then you will get a class not found exception. Okay. So this is with example. You understood, right? Okay. Now I'm going to some explanation. This is I already explained many things. Okay. So I will tell you how does it exactly works. If I am importing java.sql.connection, our code references this, right? Then JVM asks which class loader should load this, because JVM need this. So it's class loader's responsibility to bring this into the JVM. So JVM asks which class loader should load this. Then Bootstrap class loader checks java.base, not found. Then platform class loader checks platform modules. Okay, it found. Then platform class loader reads java.sql.jmod, not SQL. It will load. Okay, SQL.connection, right? Correct. It will SQL.jmod. Then class bytes loaded into metaspace. Class is linked and initialized. This is what happening behind. You simply writing like this, import java.sql.connection, but behind this much operations are happening. That is how this is getting imported. Okay, in the disk we have a JDK folder, right? So inside that we have this all modules or other jars, everything, right? So this java.base.jmod comes under bootstrap CL. This java.sql.jmod comes under platform CL. Java.xml.jmod comes under platform CL. So our application jar comes under app CL. So this is how it is inside the disk or in our JDK. But in JVM we have metaspace and a heap. In metaspace the class information comes under metaspace and the objects comes under heap space. So this is how JVM have more memory spaces. I will cover it in the next video, the entire memory. But in short, for a demonstration, if you are checking this example, our class information will come metaspace and our objects will come into the heap. So now I will go to the presentation. It will give you more understanding about these class loaders. Okay, so this is my Java class loaders explained in detail. I have added almost every details here, so please watch it very carefully. In many interviews it will be very useful. So why class loaders matter? Okay, so it runs on JVM. Java application run on the Java virtual machine, not directly on the operating system. That everyone knows. This layer of abstraction is the key to portability. That's why Java is platform independent, right? Because Java runs on JVM That's why it is platform independent. It is not directly running in the operating system. So dynamic loading. The JVM doesn't load everything at once. It loads classes dynamically at runtime only when they are needed. So the JVM does not load everything at once. It loads classes dynamically at runtime when they are needed. Okay, so in disk the classes will be there, but it will come to the JVM whenever it is required. Class loaders will do that. Core functions: load .class files into the memory, provide security isolation, enable modularity and extensibility. So without class loaders, Java would not be platform independent. Okay, because class loaders helps Java to be platform independent. So application.class files loaded by class loader into JVM memory method area bar heap. Here you can see the diagram. Okay, operating system is below, but in operating system the JVM is in operating system, but everything else runs in JVM. Java application or class files, everything runs in JVM. So what is a class loader? A class loader is a core JVM component responsible for finding and loading class files at runtime. It locates files, searches for .class files across the file system, jars and network. Loads byte code, reads the raw bytes and loads them into the JVM memory method area. Then create classes objects, transforms the bytecode into a class object for the runtime environment. This is what class loader does. So here you can see the example I already demonstrated, class loader CL. This is how you can create a class loader. Every class in Java is loaded by some class loader. If get class loader returns null, it is usually the Bootstrap class loader. That also I demonstrated. So this is a hierarchy: Bootstrap class loader, then platform class loader, then application class loader, then custom class loader. Okay. So the parent first delegation. When a class is requested, a class loader first delegates the request to its parent before attempting to load it itself. Ensures core Java classes like string aren't overdone. Provides a sandbox for security. Code insight. You can see I already demonstrated this, right? With java.lang.string, it printed null because it is Bootstrap class loader. Means if I am requesting for a dot class, first it will check its parent, then it will check its parent, then it will check its parent. If it is here, means the class loader will use whatever available here. If it is not here, then this will get the second precedence. If it is available here, it will load from here. If it is not available here, it will check here. If it is available here, it will load from here. Finally, if it is not available anywhere, it will load from here. This is the hierarchy. So default class loader is the application class loader. Our class path or our application jars, everything will be in the loaded by application class loader. That you can see in your ID classes folder and all. I will show you also. This is the hierarchy. Then Bootstrap class loader. What is a Bootstrap class loader? The Bootstrap class loader is a parent of all classes, all class loaders, and part of the core JVM. It's a top level loader. It sits at the very top of the class loader hierarchy. It has no parent class loader. Loads core classes, responsible for loading standard JDK classes like java.lang.star, util.star, io.star. Okay, this is rt.jar. Before Java 9, it was used by, we were using rt.jar. After Java 9 or from Java 9 onwards, we are using modules. Okay, so that is, you should understand, from Java 9 onwards, we are using modules. Okay, so what is modules? That I will already had demo, but I will show you where the modules are. Okay, At the end of the demo, I will show you the modules concept where it resides, everything. Okay. So first, now you understand from Java 9 onwards. Nowadays we are using modules. That's a concept introduced after Java 9, and platform class loader also. Before that, before Java 9, it was some extension class loader. After Java 9, it is platform class loader. Okay. So native implementation. Unlike other loaders, it is written in native code, C or C++, not in Java. That is important about Bootstrap class loader. That's why Bootstrap class loader, if you are trying to print Bootstrap class loader, it will print null. Here you can see it's printing null. In Java, null represents the Bootstrap class loader because it's native and not a Java object. Platform class loader, formerly known as the extension class loader. Okay, before Java 9, it was extension class loader. The platform class loader was formalized to support the Java module system. Platform class loader and the module system came from Java 9 onwards. Introduced in Java 9, replaced the old extension mechanism ext bar lib to align with the modular JDK architecture. Loads platform modules responsible for standard Java SE modules that are not core Bootstrap classes such as Java.SQL, Java.xml. Okay. The middle layer serves as the parent for the application class loader and delegates to the Bootstrap class loader. Okay. So this is about platform class loader. This is you should remember, from Java 9 onwards only this platform class loader is available. Okay, before that it was extension class loader. So it comes, parent of platform class loader is Bootstrap class loader, and the child of platform class loader is application class loader. So unlike Bootstrap, which is native, okay, the platform class loader is a Java object, so you can reference it directly in code. Okay, so platform class loader is a Java object, so we can reference it directly in the code. Application class loader. So application class loader is the default loader for all user level classes in a standard Java application. System class loader, often referred to as the system class loader, it is a child of the platform class loader. Loading sources, loads classes from the system class path -cp and application jar files. Your code lives here. Most of the classes you write along with third-party libraries dependencies are loaded by this loader. So we will specify the class path, right? So that class path is for application class loader. Okay, it is not for platform class loader or Bootstrap class loader. It is for application class loader. So we are mostly dealing with application class loader. So our classes, you can see in ID, inside target folder, there are classes, right? So these all are loaded by application class loader. So it resides in class path. Whatever we mentioned the class path, it will go there, and application class loader will check in that class path. If the application class loader cannot find a particular class in that class path, it will throw class not found exception. Okay, that is, so in interview, if someone asking you when you will get a class not found exception, you can say if in the specified class path the .class file whichever the application class loader is looking for is not found, it will throw a class not found exception. Note the specific class name. Example, application class loader might vary slightly between JDK versions, but it always represents the application level. Okay, that is on the version wise it may slightly vary. That's fine. What is a custom class loader? Java custom class loader means non-standard sources. Load classes from locations outside the standard class path. from network, from encrypted files, from external plugins. Okay, so this is why we are using custom class loader. How to write a custom class loader? We have to extend the class loader. We will extend sometimes for exceptions. We will create custom exception, right? Customizer exceptions by extending runtime exception like that. Here we can create custom class loader by extending the class loader. So it is used for load classes from locations outside the standard class path. It could be network, encrypted files, external plugins. It could be anything like that. So another case, framework integrations, essential for complicated architectures. Application servers, okay, Tomcat, WebLogic for isolation, plugin frameworks, OSGI or Eclipse, Spring Boot, fat jars, nested jars. There are some specific scenarios to write a custom class loader. So that you have to write custom class loader if you are going through such a scenario. This is some basic example, but there will be more scenarios. You should have to write some custom class loader to achieve that particular functionality, means you have to write. So provides modularity and isolation for complex enterprise system. Okay. So extends java.lang.class loader to override behavior. Means if you are extending class loader, it will means we are creating a custom class loader. Okay. Custom class loader example. My class loader extends class loader. Okay. Means this is very important. You have to extend the class loader. Then it overrides the find class. Okay. Why it is overriding? Because we have to check in a specified location, or we have to find in a different way. So we are overriding this find class based on our logic. So it will return based on our whatever we are writing the logic here. So fetch raw bytes from network or encrypted files. If you want to get from an external API or network or some other location, you can get it, you can load, you can return a defined class, you can return this. So it will return that class. This is how you can write a custom class loader. It will throws a class not found exception. If it unable to find, it will throw a class not found exception. Okay. So improper implementation of custom class loaders is the primary cause of metaspace out of memory error. Ensure classes are uploaded properly and avoid holding static references to the loader. So this is a caution. We have to make sure we are using it very properly, otherwise metaspace out of memory error will come. So why? Because the classes are loading into metaspace, right? Objects are going to heap. So out of memory error from metaspace will come if we are not using it properly. Okay. So parent delegation model, the sequence of how Java locates and loads classes. It will ask the parent, then recurse up. This process repeats recursively until it reaches the topmost parent, which is Bootstrap class loader. Third, Bootstrap first. Bootstrap tries to load the class first. If found, for example, string, it is in Bootstrap. Okay, it can load. It is returned immediately. Child load. Only if the parent fails, class not found exception is getting, then the child class loader attempts to load it. Okay, so it will go recursively. First, the child class loader asks its parent, then it asks its parent, it asks its parent, like that till it will go to the topmost parent, then it will come back. If it is not found, check in the previous, like that it will do. If it cannot find anywhere, means it will throw class not found exception. Why this matters? This mechanism prevents core class overriding. A custom class loader cannot load its own version of java.lang.object because the request is always delegated up to Bootstrap first, which finds the genuine JDK version. Okay, this is in interviews, questions may come. Okay, can we override java.lang.object or java.lang.string? So this is the answer. This parent delegation model mechanism prevents core class overriding. Okay, it's very important. Delegation model diagram. Load class, my class, initial request, application class loader delegates its parent, platform class loader again delegates the parent, Bootstrap class loader attempts to load. Okay, this is how it is delegation happening. How delegation works: when the application requests a class, the request hub bubbles up with the hierarchy before any loading attempts occur. App class loader receives the request, then does not load immediately, asks for platform class loader. Then platform class loader also delegates upwards, asks Bootstrap class loader. Bootstrap class loader checks core libraries. If found, returns class. If not found, flow goes back down. Okay, it will first go up, then it will step by step it will come down. It will check one by one. Whenever it is find, it will return. Otherwise, if it is not at all find anywhere, it will throw a class not found exception. Then class loader versus class.forName. Okay, so load class and for name. Okay, load class loads class. Yes, both the loads classes. Correct. Okay. Then initializes. Load class will not initialize. It is a lazy loading. It will not initialize. But class.forName by default it will initialize. Static block. Load class skips the static block, but forName will execute the static block. Okay. So load class will simply load the class. That's all. But class.forName will load class, initializes it, then static blocks will get executed. So JDBC drivers uses class.forName specifically because they need to register themselves with the driver manager via static block. You might have seen this many times: class.forName, com.mysql, cjjdbc driver. So why we are using forName here? Because it will load, it will initialize, it will execute the static block. So driver will get registered. Okay, so in load class nothing will happen. It will simply load the class. Driver registration or initialization, nothing will happen if you are using load class. Next, class loader memory areas. We have metaspace, we have heap. Class metadata goes into metaspace. Okay, method bytecode goes to metaspace, but heap contains static variables and object instances. Okay, the heap area contains the objects. A class can have a number of objects, right? That all the objects will come into the heap. Okay, so that's why the garbage collection must be running in heap area, because objects are getting created in the heap memory and heap memory may get full. So garbage collection is happening there. So metaspace replaces permgen, stores class metadata, method definitions, bytecode, constant pools allocated in native memory. Is a non-heap. Heap memory the runtime data area for class instance and arrays holds static variables moved from permgen. Warning: class loader leaks if class loaders aren't garbage collected. Metadata fills up metaspace. Java.lang.out of memory error will come from metaspace. Okay, so that is very important. The garbage collection, we should do garbage collection properly, otherwise the metadata fills up the metadata, so that we will get a out of memory error from metaspace. So class loader leak example. common scenario, web containers and hot redeploy. So container thread have thread local map, object, class and custom class loader. Okay, so cannot be garbage collected because the thread is still alive. Okay, if the thread is alive, that will not get garbage collected. Okay, so when an application is redeployed, the container creates a new class loader. The old class loader and all its classes should be garbage collected. Okay, so this is how it should work. Okay, when an application is redeployed, the container creates a new class loader. Correct. The old class loader and all its classes should be garbage collected. Why then leaks happening? Static references. Static fields live in the class, which refers to the class loader. Thread locals. Values in thread local map on container threads hold strong references to classes. These types of references I already did one video, very detail about garbage collection, different types of garbage collection and all, and the references, how it is happening, what type of reference will at what time it will garbage collected, everything I have already done, so that you can check my video about these references. So this is a scenario where the class loader leak happening. One is static reference, second one is thread locals. Okay, so why the leak happening means garbage collection may not happen if the thread is still alive or it have a strong reference. Okay, real world usage, Spring Boot, application servers, plugin systems, everywhere we are using this class loader. You can see common libraries shared by class loader and application A and B both have V1 library, V2 library, class A, class B, etc. So class loader A, class loader B. So use custom class loading mechanism to handle fat jars, nested dependencies. The framework creates a specialized launched URL class loader to Bootstrap and application correctly. Application servers like Tomcat and or Jetty use a separate class loader for each deployed application. This prevents class conflicts if two apps use different versions of the same library. Plugin systems, IDEs, IntelliJ, Eclipse, and frameworks uses isolated class loaders to load and unload plugins dynamically at runtime without restarting the main application. So frameworks leverage class loaders to provide isolation and hot reloading capabilities. So they will be having custom class loaders to achieve their own functionality in real world. Okay, Spring Boot, application servers, plugin systems. Okay. So interview questions. Why is string.class.get class loader is null? Because it's a Bootstrap class loader and Bootstrap class loader is always return null because it is written in C or C++, not Java. It's not a Java object. What is parent delegation model? I already showed you in the demo. Difference between class loader for name, I already explained it in detail. How do class loader leaks happening? I already explained. I recommend you to watch my reference one another video. There I explained it in very detail. What changed in Java 9 modules? That also I told you before. Java 9 it was extension class loader. After Java 9 it is platform class loader and it introduced module system and focus on why. Okay, isolation security, not just how. This is a tip only. Then I will show you in summary dynamic loading, hierarchy and types, security via delegation, memory risks, JVM internal mastery. Understanding class loaders is a JVM mastery. Okay, it's a very important thing. Then I want to show you another thing. Before that, thanks for watching this. Okay, if you like this video, please like and please do subscribe. Also if you have any doubts, please comment. It's a short video, right? So if you have any doubts, I can answer it. So please comment it. Okay, so next I will show you the platform class loader and J modules, some examples, not example, where it is exactly. So in my present working directory, you can see here inside library Java JVM, Java Virtual Machine, JDK25.jdk contents home J mods. This is the modules actually, J mods. Okay, so here you can see all the modules. It ends with the .jmod, jmod. Okay, here you can these all are the modules used by platform class loader. Okay, so if you want to check, you can check in your system. Okay, based on Windows or Linux or Mac you are using, the location may vary, but it will be inside contents home jmods. You can see the modules. Okay, then the .class files, where it comes. If I am going to my our own project, inside target you can see, right, the classes. So this is my class path, that's why my class got generated here, and the application class loader uses this path to load classes when running. Okay, whatever .java files I created, there is a corresponding .class file here. Application class loader will load this into the memory whenever it is required. Okay, that's all about this. Once again, thank you for watching this. Please do like, subscribe and comment. Thank you so much.